Okay, so now we're going to do question 3. So in this question, we are given point A, which is this one here in the diagram, and point B, which is this one, and point P, which form a triangle, so which is this one here. And we are told that BP is equals to AP. So this side of AP is equals to BP, right? And another thing is we are told that E is the midpoint of AB. So now, question 3.1, we are asked to find the coordinates of E. So we know very well that E is the coordinate. We know very well that E is actually the midpoint of AB. So we're going to use the coordinates of A and B. So having the coordinates of A being 5 and 0, and B being 7 and 6, and E is the coordinate of these 2 points. So we're going to first find the x coordinate of E being equals to the x coordinate of A plus the x coordinate of B divided by 2, right? And then equals to, so the x coordinate of A is this one here, which is 5 plus the x coordinate of B, which is this one here, 7 divided by 2, right? So it's just going to get 6. So this is the x coordinate of E. And then the y coordinate of E is equals to the y coordinate of A plus the y coordinate of B divided by 2 equals to, so the y coordinate of A is this one here, which is 0, plus the y coordinate of B, which is 6, divided by 2 will give you 3. So these are the coordinates of E. So E coordinate is going to be 6 and 3. So now 3.2 says that determine the equation of BA. So here is the line of BA or AB, this one here. So we're going to use these 2 coordinates to find the equation of AB. So we have our coordinate of A being equals to 5 and 0. Right, and the coordinate of B being equal to 7 and 6, right? So to find the equation of these 2 points, let's first find the gradient of AB, right, which is y2 minus y1 over x2 minus x1, right? So let's say this is going to be x1, this is y1, and then this is x2, this is y2, right? So meaning instead of writing y2, we're gonna write 6, this 6 here, because it's y2, and then y1 is this one here, so it's minus 0, divide by x2, it's this one, so it's 7, minus x1, which is this one, is 5. So your gradient here is going to be 3 if you punch your calculator. So now you have your gradient. So equations y is equals to mx plus c, but our m is equals to 3, so it's going to be y is equals to 3x plus c. So you're going to substitute any point. It can be point of A, which is 5 and 0, into this equation to find the value of c, right? So where we see 5, where we see x rather, we're going to put 5, and when we see y, we're going to put 0. So it's going to be 0 is equals to 3 into 5 plus c. So 0 is equals to 15 plus c, and then we transpose the 15 to the other side. Therefore c is equals to minus 15. So our equation is going to be y is equals to 3x. Instead of writing c here, we're just going to write minus 15. So this is our equation of AB. So now 3.3 says that line BA is parallel to the straight line which has this equation here. So calculate the value of R. So what we need to know is this line of BA is parallel to a straight line. We don't know in according to the diagram, but we know the equation of the straight line, which is this one here that is given, right? So and another thing that we need to note is parallel lines have equal gradients. So the gradient of AB or BA is equals to the gradient of this straight line, right? So we know very well that the gradient of AB that we found in the previous question, it was 3. So meaning the gradient of the straight line is also 3, right? So we're going to use that information later on to find the value of R. rx minus 3y plus 5 equals to 0, right? And then we're going to write it in standard form so that we will be able to see or be able to calculate this r, right? So to write it in standard form, we're going to transpose this part here to the other side. So you're going to have minus 3y and transpose this one, so it's going to be equals to minus rx minus 5, right? And then we divide by minus 3 all sides, divide by minus 3. So y is going to be equals to this negative rx over minus 3 minus 5 over minus 3, right? So it's going to be y is equals to, so the negative goes away. We have rx over 3 minus, or the negative also goes away, so it's going to be positive 5 over 3. So you have this standard equation that we have here, and you need to note that the gradient of AB is equals to the gradient of this line here, of this equation here. Let me just write line, which is equals to 3. So what defines a gradient in a straight line? Y is equals to mx plus c, right? So this is the gradient, right? So meaning in this case our m is equals to r over 3 in terms of this equation here, r over 3, of which we know that this r over 3 is equals to the 3 here, this gradient here. So to find the r, we're just going to cross multiply. So it's going to be r is equals to 3 times 3, which is equals to 9. So this is the value of r. So now 3.4, we are given an area of triangle AOP, which is equals to 10 units squared, and we are told that y is less than 0. So whatever value of y that you're going to find in this question is to be less than 0. If it's greater than 0, then there's something wrong with your calculations. Calculate the coordinates of P. So we want these coordinates of P here, but we are given the area of this portion here. I'm just going to, so even though my triangle doesn't look accurate, but this is, let me just shade it. So this is what we are looking for. We are looking for the coordinates of P, and we are given this area here. Given this area here. So this is O, this is A, and this is P. So now we're having the diagram. It looks more like this one, right? And we have our P here, which is what we are looking for, X and Y, right? As you can see on the diagram here. And we are given the value of A, which is 5 and 0, right? This one here. And we are given the origin, which is 0 and 0, right? So those are some of the information that we have. So the origin is 0 and 0. A is 5 and 0. The area is given as 10 units squared, right? So the first thing is, let's identify the area of a triangle. Area of a triangle is half base times height, right? So we're going to take this as the base. Why am I taking this as the base? Is because this side here is going to be our perpendicular height. All right, so if we go to our diagram, you'll see what I'm talking about. So this portion here is going to be our perpendicular height. So if this is our perpendicular height, then this, from this point up until this point, is going to be our base of the triangle. This is the triangle, right? It looks like this. So this would be our perpendicular height. Cool. So now we have half. What is our base? It's OA multiplied by our height, which is unknown. So area is equals to, so our area we're given is 10 equals to 1/2. And then our A, since it's from this point up until that point, and we know that the x value of A is 5. So it means now, because it starts from the origin and then it goes to A. So we're just gonna write 5 here, multiplied by H. Then we cross multiply, we have 10 times 2 equals to 5H. Divide by 5 both sides, we have H being equals to H being equals to 4 units, right? So our height is equals to 4 units. But remember that H is actually a y value if you look at it in terms of the diagram. So you can conclude that y is actually equals to -4, right? Why am I saying that? If you take a look at your diagram, and what we just found here is we just found the y value of P, this y value here, which means from this point up until that point, since it's our perpendicular height, it's actually our y value, which is equals to -4, since from this point going downwards it's -y. Okay, fine. So now we have our y value being equals to -4, right? But we need our x value now. So we need our x value of P. We don't know it. So for us to find that x value, we need to remember the information that we are given. We were told that AB, so this line here, AP is equals to BP. So basically that means now that the distance of BP is equals to the distance of AP. So we're going to write that expression here. So what we have is, we know the formula of a distance is equals to the root of x2 minus x1 all squared plus y2 minus y1 all squared, right? If I write it in terms of distance squared is going to be x2 minus x1 squared plus y2 minus y1 squared, right? So we're going to use this equation here to really find our value of x, right? So we know very well that AP is equals to BP, right? So reason is we were given this statement. So this means now that our value of A, we know it as 5 and 0. Our value of B, we know it as 7 and 6. Our value of P, we now know the y value, which is -4. So we just want this x value. So we're going to write this AP in terms of distance form. So we're simply going to say, we know very well that this distance is actually equals to the root of x2 minus x1 all squared plus y2 minus y1 all squared is equals to x2 minus x1 squared plus y2 minus y1 squared, right? So we're having square root of so this is the square root of AP. This is the distance of BP, right? So we're just gonna remove the square root. So to remove the square roots, we're gonna square both sides, so they'll disappear. We'll remain with x2 minus x1 all squared plus y2 minus y1 all squared equals to x2 minus x1. So let me write this properly. Minus x1 squared plus y2 minus y1 squared. Remember that this is for AP and this is for BP. So let's substitute those values. Let's substitute the value of AP. We know A is given as 5 and 0, and P is given as X and minus 4, right? And this side we know for BP, we know B is equals to 7 and 6, and P is X and minus 4. So we're going to substitute these values in these distance equations, right? So let's say this is actually our x2 and this is x1, so this would be our y2 and this would be our y1, right? Same goes here. Let's say this is x2, this is y1, this is x1, this is y1, right? So this is y2 right there. So we're going to substitute these values according to what I just did. So instead of writing x2 here, we're going to write this 5. It's going to be 5 minus this x1 here, which is x squared, plus, and then our y2 is 0, minus our y1, which is minus 4. So it's going to be minus 4 squared equals 2. And then this side here, x2, is going to be this 7 here. So it's going to be 7 minus x1, which is this x here. So it's going to be x squared plus, and then y2 is this one here, which is this, sorry, y2 is this one here. So it's going to be this y2 here, which is 6, minus y1, which is minus 4. So it's minus 4 squared like this. So we're going to have 5 minus x squared plus this negative multiplied by this negative gives us positive. So it's going to be positive 4 squared. Why? Because you have 0 plus 4 is equals to 4 right here inside, and then equals to, we have 7 minus x squared plus, and then 6 minus 4, which is going to be 6 plus 4 squared. Right, so remember we're trying to find the x value of P. So we're going to have 5 minus x squared plus 16 equals to 7 minus x squared plus, so 6 plus 4 is 10 squared. So we're going to have 5 minus x squared plus 16 equals to 7 minus x squared plus 100, because 10 squared is 100. Then we're going to find the product of this and the product of that by expanding. So we'll have 5 minus x plus 16 equals to 7 minus x and 7 minus x plus 100, right? So 5 multiplied by 5 will give us 25, right? And then 5 multiplied by this negative x is minus 5x, and this one here minus 5x plus x squared plus 16 equals to the 7 multiplied by the 7, it's 49. 7 multiplied by negative x, it's minus 7x, and this one also it's minus 7x plus x squared plus 100. So this x squared, because it's at this side of the equation, and this one is on the other side, and they have the same signs. If I take the one to the other side, it's going to be negative, so I'm just going to cancel them out, and we will remain with 25 minus 5x minus 5x plus 16 equals to 49 minus 7x minus 7x plus 100, right? Let's add these like terms here. So it's going to be 25 minus 10x plus 16 equals to 49 minus 14x plus 100, right? So now we're going to add the like terms for this one and this one. So it's going to be minus 10x plus 14x equals to 49 plus 100, and then you transpose this one and this one to the other side. We have minus 25 minus 16, right? So so yeah, minus 14 plus minus 10 rather, 10x plus 14 is going to give you 4x equals 2. So you're going to add the entire numbers here, and then you'll get 108, and then you divide by 4 both sides. So your x value is equals to 27. So this means now that your coordinate of P is going to be 27, which is your x value, and your y value is 4. So these are the coordinates of P.